Every day we have a homework assignment that I feel needs to be talked about. We're going to start class that way. All right. So the last homework assignment I gave you, you guys, pretty much everybody got hundreds on it, so we didn't really talk about it in too much detail. You guys did extremely well on this one as well, but there were a handful of questions that I want to discuss and point out. Ultimately, because either they were the ones that were most missed on the assignments, or they are ones that directly link to a question that's on the end of course exam. Okay, so there's always a reason for the madness in regards to the questions that I present you in class when we talk about them. If we go over, so we're going to go over three here. If we get through those three and you had one that I didn't cover, and you want to talk about it, let me know, and we'll talk about it. Okay, I have no problem doing that. I'm extremely flexible with schedules and stuff like that, and being able to, if I have something planned one day and you guys come to class and you say, I had absolutely no idea what's going on, and we spend 50 minutes going over just the homework questions, and I put my plans on the back burner and we can pick them up tomorrow. Does that make sense? I'm okay doing that. The first one I want to see, these were all towards the end. This one here says, on a number line, suppose point E has coordinate of 3 and EG is 7. Okay? Now, remember what EG means. That's distance EG, right? Or length EG. And make sure my mic was on. So I'm going to draw a picture here. I think the number one thing, guys, especially in this class, is if you are struggling with a concept, draw a picture. Okay, so I'm going to make a number line. It says E has a coordinate of 3. And it says EG has a length of 7. So there's another endpoint out here somewhere, okay, that is going to fall at a position that makes the length between E and that endpoint 7 units long. So if that little blue segment there is 7 units long, what does the position of G have to be? If you stood at 3 and then you walked 7 units to the right, you would be located then at 10, wouldn't you? Okay, so we're looking at the coordinate of G to be 10. And the people that missed this question had that as one of their options. But it says, what are the possible coordinates? Okay, that's not the only answer. Okay, nothing in this question states that we had to go to the right. Could I have started at E and worked 7 units that direction? So that would be a point there, right? What would be the coordinate of that point right there? 7 units to the left of 3. -4. Okay? So those are the two coordinates then that we're looking for in that particular question. All right? Like I said, a lot of people, because we're accustomed to, we're comfortable with moving towards the right on a number line. Okay? And that I think is instinctual. But then that last one, going to the left and find that -4, is also one that we have to think about. Questions on that? If something ever doesn't make sense, guys, this is your education, right? So if something doesn't make sense, do not hesitate to throw up a hand or just interject and say, I don't get it, stop, start over. This is the way I think about it, whatever. Let me know, and we can approach things that way. Let's talk real quick about 2 words before we get into this question. Let's talk about the word imply. Okay? If I'm going to imply something, let's use this analogy. Let's say you come to class, and I started saying, you know what, today's Thursday, and what's tomorrow? Today's Thursday, tomorrow's Friday. You know what I really like to do on Fridays? I like to give in-class assessments. I really like to do that on Fridays. And tomorrow's what? Tomorrow's Friday, because today's Thursday. Today's Thursday, tomorrow's Friday. I like to give in-class assessments on Friday. And if I was going to give an in-class assessment, maybe I'd look at vocabulary, some postures, or whatever. But that's just saying if we had an in-class assessment tomorrow. Because tomorrow is what day? Friday. You got any quizzes tomorrow already? For other classes? 2 or 3? 2 tests? So maybe tomorrow you'll have a test and a quiz then maybe. What am I implying that's going to happen tomorrow in class? An assessment, right? Possible quiz, right? I didn't come out and say the word quiz. I didn't come out and say, Hunter, you're having a quiz tomorrow in class, right? I hinted towards it though, right? Okay? So when I'm hinting towards something or I've got information that's hidden from you, but I give you enough contextual clues to where you can say, I know what's going to happen tomorrow. I'm implying a quiz. Does that make sense? I'm being, a word that we're going to see a lot of times is that we're being implicit. Okay? Or I'm giving you implicit information. If you come to class, you sit down and say, quiz tomorrow. Is there any implying being done there? No. There I'm being explicit. Does that make sense, everybody? And the reason I need to talk about those words is because throughout the entire year, we're going to see information that is implicit, and we're going to see information that's explicit. And through other math courses, you're actually going to talk about things called implicit equations and explicit equations. Okay? You've probably dealt with both. Okay? To give you an example, you guys remember seeing something like this last year? Like I say, 2x plus 3y equals 12. Remember seeing that? Okay, and you work to rewrite that as maybe y equals negative 2/3 x plus what, 4? Okay, this here is what we call an implicit equation because x and y are on the same side. This here is called an explicit because I'm telling you exactly what y is. Correct? That makes sense, everybody? So telling you exactly what something is explicit. Kind of hiding it, and look at the 2x plus 3y equals 12. We call that standard notation. When I look at that format, I got to do a little bit of work to find what y is, right? I got to do a little bit of work to find out what x is. Okay? So I'm implying what it is, but it's kind of hidden. Okay? And the reason I want to talk about that is because there's, in this question, there's some implicit information and there's some explicit information. Okay? Does this tell me exactly what AD has to be? AD, which is that length right there, is 8. Okay? That is explicit information. They're telling me exactly what I need to know for AD. Is there anything in regards to the terminology, the words used up here, that tells me what the length DC is? Does it ever say DC is this number? No. Okay? But they hide that information. Right here and right here, those symbols tell me that those segments, AD and DC, are what to one another? They're congruent. Okay? And if they're congruent, that means their distances are equal, right? So if their distances are equal and one of them was 8, what's the other one? It's 8 as well, isn't it? Do you see how they implied that DC's length is 8? Or they hid that to me or for me? Okay? And we got stuttering. We got to kind of play that game where we're trying to uncover information that they're hiding from us. Kind of like brain teasers or riddles or something like that, where all the information's there, we just have to find it, have to uncover it. So now that I have that, okay, what is a length of A to C then? If A to D is 8 and D to C is 8, what's A to C? 16. If I write this, AC, one way of describing AC says is 2y minus 18. But we also have AC is 16. Are these two things the same AC? Are we talking about the same segment AC? then if those two things are the same, what's that tell me about these two things? They got to be the same as well, right? Okay, so we got 2y minus 18 should equal 16. And that allows me to set up that equation. That's the relationship that they are implying here with that information. Okay? If you can do that, you've demonstrated that you know your geometry. Okay? Now the remaining part of this, and what you're actually graded on, is the algebra, because they're going to ask you what is y, right? Well, I could do all the geometry correctly, but if I suck at algebra, it doesn't matter whether 2y minus 18 equals 16 was right? Okay? So I have to demonstrate that I'm also proficient at my algebra, so I add 18 to both sides. Okay? So what's that going to give me? 34? And then y will end up being 17. Okay? A lot of questions you guys are going to find out, it's one step or two steps to apply the geometry that we've learned. The geometry part of this class is not hard. Okay? It's then the 3, 4, 5, 6, 7 steps after that are all algebra that I need to conduct. Okay? And that's the thing about the end of course exam, is that you're going to be asked and graded on your proficiency in regards to geometry, but in order for them to judge whether you know you're doing your geometry correctly, they're going to ask you for what y is. They're going to ask you for what x is. They're going to ask you maybe some question in regards to a graph where you had to apply some geometry, but then you probably applied more algebra than you did geometry. Does that make sense? Okay, so that geometry test at the end of the year it's a mixed bag of geometry and algebra. Okay, so if you got like a 2 on that test last year, my argument is if we don't refine those skills any better, you're kind of hamstringing yourself to do well in that end of course exam for geometry. Okay, does that make sense? This is the next one that we struggle on, and every year this is a question that is problematic, but it is one that models some things that I've seen on the end of course exam in the past. Okay, so I think it's important to be able to address this. And I'm actually going to, let's move things around a little bit here. So here's the diagram, and it asks for an algebraic expression for GK. So I'm looking for G to K, an algebraic expression for this thing. Meaning it's going to incorporate variables and constants. All right, so the idea is if I'm starting at G, okay, I'm standing there, and I want to walk to K, how far will I walk? Okay, does everybody agree that I'm going to at least walk up to J? Does that make sense? So I'm just going to write that GK, first of all, is equal to GJ, and then we'll follow that up by walking JK. Is that all right with everybody? So walk from G to J, take a break, then walk from J to K. All right? So when I do that, G to J, we have an expression for that, right? G to J is 4x plus 5. So that's what that is. Plus then, okay, so here's where a lot of people ran into an issue. If I'm right there at J, and I want to get to K, do we have a set of purple information here that says what J to K is explicitly? No, it's kind of hidden, right? Okay, G to K is only that distance right there, correct? So it's almost 6x minus 3, but I got to remove that amount, don't I? Well, how much is that amount? Isn't that amount x? That kind of makes sense. Everybody see the overlap between these two? So I can't just simply Well, what a lot of people have been doing is taking that expression, 6x minus 3, and that one of 4x plus 5, and add them together. Well, if I just add those together, think about it this way. If I just add those together, so I give myself that segment, adding together is putting end to end, right? Don't those two things end to end go past k? And it's because they both add in this x. So what I need to do is somehow remove that x. So I'm going to remove that x from here. So if I take 6x minus 3 and remove x from it, what's that give me? 5x minus 3. And that is my expression then for jk, 5x minus 3. Does that logic make sense? Okay. You guys have maybe done that. You guys deal with probability all last year? Ms. Coles, get to that. Mr. Hurd, get to that? No? Yes? You guys' next work? You can go up and down, left and right, or shrug, don't know? Okay. Maybe you've worked with probability in regards to, like, if I ask you what's the probability, I give you a deck of cards, and I ask you what's the probability of picking out a red card or an ace, okay? How many red cards are there? Anybody know how many cards are in a deck? 52. So 52 cards, so half of them are red, right? So you got 26 red cards. How many aces are there? 4. How many of those are red? 2. So if I ask you the probability of picking out a red card, it'd be 26 out of 52, right? Or an ace would be 4 out of 52. Does that make sense? Say again? Okay, yes. So here's the thing. So let me write this down so we keep track of this. If we've got, so the red cards were 26 out of 52, right? The aces was 4 out of 52, right? Are there 2 out of these 26 cards? Are 2 of them aces? They are. Okay, because you have the red one, you got the ace of hearts and the ace of diamonds, right? And these 4 aces, are 2 of them the ace of hearts and the ace of diamonds? So you see how the ace of hearts and the ace of diamonds got counted once here, and they also got counted once there? So in probability, what we have to do is remove those 2 cards, because they got counted one time too many. Okay? That's what's going on right here if I put these things end to end. This distance of x gets counted in one too many times, so we have to make sure we remove it. Does that make sense? Okay? There are times that I like to kind of make connections between things that maybe you've already learned. If you haven't learned that stuff with probability, we will before the end of the year. We'll talk in great detail about probability. But we got to make sure in this case that we remove that x. Okay, so our answer here then would be, what, 4x plus 5x is 9x's? Plus 5 minus 3 is plus 2. Okay, so there is the algebraic expression for GK. All right, now they ask us to continue. They say if GK is 56, find GH and JK. Excuse me. So what can I replace that thing there with? 56. So 56 is equal to 9x plus 2. So 54 is equal to 9x. Okay. What's x going to be then? 6. Okay. So here's the thing. They then ask us, what is G to H? I want to know, what is that distance right there? Okay, so I'm going to plug in, and am I going to use that right there? Doesn't that go from all the way from G to J? So instead of using 3x plus 5, I'm going to use, 4x plus 5, I'm going to use 3x plus 5. Does that make sense, everybody? Okay, I don't want to go all the way to J, so I'm going to stop short. So plug my 6 in there, and I get 23. Okay, so G to H is 23. Isn't this distance here 6? H to J 6? And then they ask me, what is J to K? Well, it's just from here to there. So it's 5x minus 3 instead of 6x minus 3, right? 5x minus 3, so plug in my 6. So it's going to give me 27. How can I check to see if I've done this correctly? Yeah, that number plus that number plus that number gives me that number 56. Okay? Now, I understand that was a long discussion about one problem, right? Okay? But I'm only going to discuss things in that type of depth if they're important, okay? If it's something that won't be on the end of course exam, if it's something that won't be on a test, something that you're not going to use in another course beyond this, I'm not going to spend 10 minutes talking about it. Does that make sense, everybody? So when we talk about something in great detail, it's because of that fact that you're going to need to know that kind of logic later on for something else. Okay? So those were the three questions that I was concerned about. Are there any that you guys felt that I didn't talk about that you need to talk about, that you're confused with, struggling with? If not, what I would like you to do is get out some paper and pencil, whatever you're doing your notes in. And I want to work through two more examples of segment addition with you, just to get practice, in case we have something tomorrow during class. If we do have something tomorrow, while this is loaded, if we do have something in class tomorrow, like a quiz, it's only going to be maybe 20 minutes, 25 minutes, because I do have some other things on top of that I want to talk about. And it's going to mostly be vocabulary, basically what we've talked about so far. Maybe some understanding of your postulates, like two planes, when they intersect at exactly one line, that type of thing. So those are maybe some ideas that you would maybe address this evening in preparation for maybe a quiz tomorrow. All right, so I've got A, let's go B and C here. I want you guys to find, on your own, find length AB and find length BC. One thing that I am terrible at is giving you something to work on and then poorly judging how long that should take you, okay? So if I give you something and you're still working, just let me know, okay? There will be times where you keep on working. I'm just going to talk over you, and hopefully you can listen to some of the things I'm saying. Did anybody write AB plus BC equals AC to begin with? That's awesome, okay? For you two. Everybody else, I want you to start doing that, okay? For the mere fact that with mathematics, the way you do things procedurally and notation-wise becomes very critical, okay? And I want to train you to kind of understand that when I'm doing a segment addition, that is the geometry, okay? Everything else after this is strictly algebra, okay? So if you could come up with that, or you knew that without even writing it, you have gained all the geometry that I needed to teach you, right? Does that make sense? Everything else is algebra. What you're going to find out is that we're going to do something in the next couple of weeks called proofs, okay? Within proofs, you're going to need the ability to recognize the AB plus BC equals AC. And if we can practice that stuff now, train ourselves to write that down now, when we start working inside proofs, it's just gonna be natural. It's gonna be really easy. Okay? But if we don't do that, we're gonna have to retrain ourselves with notation when we're trying to learn how to do something that is very difficult. Okay? Proofs are not generally the easiest things to do. Okay? So my whole story, we can start writing that stuff down first. So then AB, that turned into 7x, right? BC turned into 5x minus 3, and AC was 45. Now what we did there, that's algebra. That's substitution, right? Which is an Algebra 1 concept, okay? Everything else you do, combining like terms, that kind of stuff is Algebra 1. So when I get 12x minus 3 equals 45, that's algebra. 12x equals 48, that's algebra. X equals, did you guys get 4? X is 4. So what's AB then? 28, when you plug back in, and then what's BC? 17. If I add those together, do I get my 45? So it's my check, right? Everything up there, guys, except for that line right there, was algebra. Okay? And that's what I need you to understand. You might be going through things and think, I'm getting bad grades, I don't know the geometry. It's not the geometry usually that people struggle with in this class. It's the algebra. Okay? So if you're doing poorly and I can help you make that recognition, maybe there are some things that we need to refine algebraically. Okay? And I can point you to resources to help you do that if you're a person that knows they struggled with algebra. Okay? Let's do one more and we'll be done. Let's do this one. Yeah, so, wait, hold on a second. So this is,
because this 7 and then this is negative 1 plus 1 here, 86, and then that's so 86, right?
7 times 12, no, that'd be 8, so 7, 84.
So
what's going to happen, so 86 and 7 don't share any factors,
yeah.
So it's going to leave it at 86 or 7.
Okay.
And then finding QU and UV is going to be a pain in the butt, or QV and VU is going to be a pain in the butt, but we're going to walk through it. But you're on the right track, just simple. So let's kind of, it seems like maybe some of us are getting to that point, and I heard some calculators open up, so I want to talk about that as well. First thing, guys, when we write these, you can write, QV plus VU equals QU. I think that's the most natural way of writing this, and that's the best way for several reasons. If I write it as VQ plus VU equals QU, because that's right, or I could write it as VQ plus UV equals maybe U equals UQ, that's right as well. But I like this one here, and most textbooks are going to write this one there, because those V's right there, like if I took the plus sign out and merged those together, would those V's overlap each other? And it's easy to see then that V is the point that both those segments share. Okay, it's the point that is in between Q and U. Okay, So I think the best thing to do when we're writing these phrases is to go left to right. Now, as you do the algebra here, I think a lot of us are finding that we've got, 4m minus 7 plus 3m plus 6 equals 85. That's going to end up giving you, 7m is equal to 86. And then m is equal to 86 divided by 7, right? And that's when I heard the calculators open. Okay? 86, think about this. Does 7 go into 8 evenly? It doesn't go in evenly, but it goes in at least one time, right? So I have a remainder of 1 left over, right? So that'd be 16 total being left over. I got a 10 left, and then my 6 in my units place. So I got 16 left over. Does 7 go into 16 evenly? No, right? Okay. So 7 is not going to divide 86 evenly. 7 is what kind of number? Where it's only divisible by 1 in itself. What kind of numbers are only divisible by 1 in themselves? Starts with a P. Prime. Okay. Now 86 is divisible by 2 and gives me 2 and 43, right? Okay. Now I believe 43 is prime. Okay. So if I look at 7 and 86, they don't share any factors, meaning they both don't share like a 2 that divides both of them evenly, or they don't both share a 3 that divides them both evenly. That means they're relatively prime to one another. That means they don't reduce any. Does that make sense? And then I heard calculators opening up, and if I say 86 divided by 7, does anybody have that up? Drake, what is 86 divided by 7 as a decimal? Two, 8, 5, 7, what? Okay, so it just keeps going. And the 9 that he sees is not the last number. It's been cut off. That number is going to keep going on forever. Okay, and there's going to be some type of repeat eventually because it is rational. However, we have to chop that off somewhere, right? Maybe I chop it off 12.2 or 12.3, round it, or 12.286. Okay. But when I chop it off, is that really the value anymore for m? No. It's an approximation now for m. Therefore, if it's an approximation for m, and I plug it back in to find QV or VU, do I really have what QV's length is? No, I've got an approximation for it now, right? So that thing with, we've been trained to do this in other courses, like 7th grade and 8th grade, to grab our calculator and just change that to a decimal and round it. When I want to find QV's length, this is what I want to do, guys. I want to go 4. I'm going to leave this as 86 sevenths and subtract 7. Now, when I multiply this out, that's going to give me, I think, 3. So my 4, carry my 3, or 2. Is this 344? $86 times 4? Drake, real quick, 86 times 4? 344. Okay, so 344 over 7, right? That's how we do, this is a fraction times a fraction. Okay, so 1 times 7 is my denominator. And then I got my minus 7, right? If I'm going to subtract those, what do I need? No. Common denominator. What's the common denominator going to be? 7, right? So does that still say 7 right there? No, that says 1 now, right? So what do I need to do to the top? What's the top need to become? 49, right? Now that still says 7. So if I do that subtraction, that should give me, what, 295 over 7? There's my length that I'm interested in for QV because there's no rounding there, right? That's the exact answer. And there will be times where Math Excel wants the rounded version and it accepts it and it's okay. But there's a lot of times where it wants 29 or 295 over 7 as well. Okay? No homework tonight. Okay? Free up a little bit of time for you to maybe prepare for a potential in-class assessment tomorrow. Because tomorrow's Friday.